Hello, hi, this is Mr. Gagnon again, and we are going to look at vectors. And we're going to work off that original riverboat problem that we had worked on, where I was in trouble, and I had to, and I realized that the boat that I was in had a lower velocity than the river that was pulling me into the ocean. So here's the other situation. Okay, let's take a look. And we're going to draw another river. Okay, here's the river. There's a bank on this side, and then a bank on this side. Okay, so now we're going to take a peek at two dimensions. Don't let it confuse you. Don't let it scare you. All it is this. Okay, if we have a river that's flowing 3 meters per second north, and we have a person that wants to jump into the river here, right about here, and start swimming across the river. And let's say that person is able to swim 2 meters per second, and they're going to be going in the east direction. So we've got a 2 meter per second vector plus a 3 meter per second vector. But the problem is we can't add these up linearly. They have to be added up quite differently. Okay, so the 2 plus 3 will not work. So how do we do this? Well, I'm going to tell you that to add a vector together, okay, all you're going to do is add one vector. We'll call this the 2 to the other vector, and then this vector is attached to the head of the last vector. So this is our 3. Okay, so it doesn't actually matter how you add these together. They are commutative. Okay, 2 plus 3 is 3 plus 2. So whenever you add these together, you're going to come up with the same answer. So my question is, what is the resultant velocity of the swimmer? Okay, so the swimmer jumps in right here. Okay, they start swimming across the river. If they swim straight across, or they aim straight across, they're going to end up somewhere upstream here. Okay, so the only question I have for you is, what is the resultant velocity of the swimmer? Okay, so to add these up, we've got to realize that we have a 90-degree angle here, and that we can actually find the velocity right here. Okay, so that's a very good possibility with our knowledge of a right triangle. So to find the magnitude is pretty simple. We know that we can even call this x if you want. X equals the square root of 2 squared plus 3 squared. Okay, so we've got 4 plus 9, 13. So x is the square root of 13. Okay, so x ends up being 3.6 meters per second. Okay, so the idea is that I figured out the magnitude of that. So that's 3.6 meters per second. So we know one thing, that the swimmer is going to swim 3.6 meters per second, like that. Okay, they're going to aim straight, but the river is going to push them up. So they end up going faster than they could originally swim because of the river pushing the person up. Now, the second question I would have, this is not a velocity, this is just the speed. We need to know at which angle is this person going at. Okay, and we call that bearing. So if I clean this up a little bit, and I just get my triangle here, okay, and realize that I've got a 2 here and a 3 here, I've got to figure out this angle. And so how we do that is use a little bit of trig. Opposite and adjacent, so tangent angle is 3/2. Okay, angle is 3/2 times tangent to the -1. Okay, so the angle ends up being 56.3 degrees. And if we look at it, it's actually, if we were to draw a coordinate plane here, this is the east line, and the vector here is north of the east line. So our angle is 56.3 degrees north of east. So here is our answer. Okay, we got a 3.6 meter per second velocity, and the guy's headed off at an angle of 56.3 degrees north of east. Okay, so that's a simple two-dimensional vector addition problem, and I've got plenty of problems for you guys to work out, so we'll stop there. Okay, thank you.